Uh, okay, so thanks for bearing with us here. I had some unexpected health emergencies. I think I'm through the worst of it, and even if there are some troubles down the road, Andy Catlin is now more involved, so he will be able to keep things moving in my absence. Unfortunately, we didn't have that set up when I disappeared there shortly. So hopefully from now on it'll be smooth, even if I do need to take some time off. But I'm also hoping that doesn't happen. So with that said, I guess what questions do folks have? I'm still digging out through all of my email and through the discussion boards, but feel free to ask even if you've already asked before. Just let me know what questions you have.
Hey Mike, it's Antil. Are there going to be more videos or
There are. I'm really limited in the number of hours that I can do stuff each day, so it's just going to take a little bit of time. So my goal is starting tomorrow to release 2 new videos each day. That should be a modest goal, so I think that'll be doable. But obviously they're not quite there yet. So you can see here, you guys aren't able to see the stuff that's grayed out yet because there's nothing in them yet. But that's the plan here, is to, over the next 6 or 7 days, to fill in some videos in each of these 3 categories. So in the meantime, you've got the book and the problems assigned, and you can start working on them and discussing them with each other. And then the videos will come as we get them up. So. Other questions? Questions on any particular problems or the group assignment? Has everybody been able to access your group?
Yep.
So this may seem an odd request, but there is no button that I can click that actually shows me the student view. So for instance, if I go to the weekly materials for this week and I look at week 2 and I click on assignments, in edit mode I can see everything, but if I turn edit mode off, which shows me my corresponding student view, I lose the group assignment. So I'm wondering if there's a volunteer willing to share their screen and actually show what they see. Anybody want to volunteer? Okay, who was that, though?
That was Mauricio.
Mauricio, great, thank you. Let me make you presenter. It's one of the weaknesses of Blackboard, is that it does not actually let us see the student view clearly. So, Mauricio, if you would log into the course, I'm going to assume everybody knows how to do that at this point. But if you scroll down from the main page, so click on Statistics, and then if you scroll down on the left, you'll see My Groups and then Collaborative Group 3. So he's in Group 3. Everybody should have a group there, and you should have access to all of those resources. So there's a collaboration tool that you guys can explore if you want to try that. And then you've got a private group discussion forum that I can access, but only your group and instructors can access. And then you've got a file exchange and various other resources. And if you actually click on the group homepage, I believe, it should list your members of your group there. So you can see that group has 4 people. Some of the groups have 3 and some have 4. And that's where you would submit your collaborative assignment there. Only one person will need to submit your final assignment. But it is like all other assignments, or at least it should be set up so that you can submit as many times as you like, and it's only the most recently graded attempt that counts. So let me know if you have any challenges or questions. We also set up a discussion board specifically for technical issues. So if you, Mauricio, if you would do me a favor and click on the discussion board, not for your group, but for the course. You should see there, if you scroll down, technical support for group resources. It's right above discussion for week 4.
Yeah.
So nothing's there yet, but if you have any trouble, you can post there, and we'll be monitoring that as well. And so that way, if anybody else is having trouble, they can see what else people have done. And it usually works all right. You guys are pretty smart, and it's relatively straightforward. So I'm not anticipating a whole lot being in this forum, but it is there if you need it. And let me know if you have any questions. And I'll probably say all of this again briefly tomorrow at our meetup for everybody. Okay. Thank you, Mauricio. Are there any questions on that?
Hey, Mike, it's Until again. The navigation is okay in the site, but sometimes it's very hard to find the assignment link. I mean, sometimes I have to dig through. I still don't know. Sometimes I don't know how to find the link to submit the weekly materials.
Oh, okay. So Mauricio, if you would go ahead and click into week 2.
Yeah, so just click on weekly materials, and now I'm going to click on week 2.
And then in the assignments folder, and then if you click on the header for the assignment, so week 2 individual assignment, if you click on that, it'll take you to this page which gives the instructions, and then you can click on text submission to write a submission. But what you're going to need to do, because you're sharing files with me, is click on attach a file. And you don't actually need to submit any text or comments if you don't want to, but you can submit extra stuff that way. But really, if you have a PDF file, you would click on Browse My Computer and then select, use that to navigate to your file and then attach it. Is that easy enough? So
okay, that should be fine.
Okay, yeah, and if you have any trouble, as a last resort, you can always, if the deadline is coming up, you can always email it to me and say, I'm having trouble submitting it. We'll figure out how to submit it later so that we have it in the course, but at least that way you've gotten it to me. And that's not a big deal. That said, I've also made one other change to deadlines. And Mauricio, thank you very much. I'm going to go ahead and take presenter back, but if we need to do more sharing, we can. But for now, I'll go ahead and take it back. I'm making one change to the deadlines. So you'll notice that this assignment number 2 has a soft deadline of next week, Wednesday, February 25th, by the end of the day. And what I'm going to do is have the soft deadline be meant to be what keeps you on pace for the course. So obviously we're a little bit behind, and I'm not going to push too hard to catch up because that could be dangerous if we try and speed things up. But so I'll just cut little bits of material here and there and just make them available optionally. But what I'll do is have an optional a soft deadline that you should try and have things done. But then, we all have things come up. Obviously, I had a major thing come up. And so I'm going to have a hard deadline that's typically going to be 1 week later. So that should allow you enough leeway to, if stuff comes up, that you have a little extra time, or if you need a little bit of help on something and you haven't had a chance to get together with me, that gives us another week to get things sorted out and submitted. The downside to this is that we can't post solutions until after the hard deadline. But that said, we can certainly discuss problems in office hours and meetups, and so I feel like that shouldn't be too big of a limitation. I'd rather you guys have a little bit of leeway for getting things done, because there is a lot to this course and to the program. So that's going to be the way we do the assignments from now on. The group assignments I would like to have harder deadlines for, because I want to use our meetups to talk about them. So for those, I will try typically to have, so for week 2, let's see, let me go back to edit mode. You'll see here that there is a deadline of March 6th on this, and that's primarily so that we can then talk about it at our next meetup. Although I'm not sure exactly where the date falls. So let's see. So tomorrow is our next meetup on, let's see, that's the 17th. Oh, so this actually falls just after our next meetup. Okay, well that's. I'm not going to do soft and hard deadlines for the group work. I think that'll just make it confusing. But certainly, if you need a little extra time, I'm pretty flexible. So Not all instructors are quite so flexible on deadlines, but I will be, especially given my own situation. Okay, so let me know as you have questions or concerns on any of that. Let me see. So people have asked a couple things in the chat window here. Let me just take a look. Somebody has asked about problem 2.12. So let me find that. First things first, let me find the textbook here on my Kindle, and then I can actually show it on the screen. There, here. Okay. So let me see if I can throw this on the screen. Are you guys able to see the textbook now? Anyone?
I can see it.
Yeah.
Okay, great. So
Yes.
let me find problem 2.12. Unfortunately, the Kindle version is not the easiest to navigate. But let's see, 2.12. Here we go. Okay, so I think we did this in office hours. A few of us did this in office hours 2 weeks ago, right? So let me just remind myself of this problem. Okay, so probably the easiest way to visualize this is with a tree diagram, but then we'll also do the formula version, and we'll see that it should be pretty much consistent here. So that actually has the full solution on it right here. Let me start fresh. I think it's easier just to start fresh. Let me draw a Venn diagram, and we'll do this. So I think visualizations of this stuff are crucial for understanding it well. So I really would encourage you guys for these problems to draw Venn diagrams, draw tree diagrams, depending on the type of problem, and use those. And then don't stop there. Once you get a solution with your visual technique, try to map it back to the formulas. And so, okay, so let's see what information we're given. We're given that the probability of A is equal to 1/2. We're given that the probability of B complement given AC is equal to 1/3. And we're given that the probability of C given A is equal to 1/4. So let me see if I can clip that and put it on our paint diagram here. And let me see if that pastes in. Yes. Okay. So let's just remind ourselves of what all the different regions represent. So the entire circle for A then represents the event A. So the probability that you fall in that entire circle is equal to 1/2. So I'll shade that circle so we know what we're talking about. The gray circle now has an area of 1/2. The probability that you're in the circle C, given that you're in the circle A, is 1/4. So let me shade that. So that orange region now is that you're in C, given that you're in A. So the orange region is now 1/4 of the total area of the circle of A. So remember, we've restricted ourselves to A. That had an area of 1/2. The orange region is now 1/4 of the area of A. It's multiplicative. So the orange region now has a probability of 1/4 of 1/2, which is equal to 1/8. So let me make a note of that over to the side. So orange region has a probability of 1/8. And so that we've used 2 of our 3 pieces of information. And the last piece that we're given is that the probability that you're not in B, that you're in B complement, given that you're in both A and C, is equal to 1/3. So I'm going to mark that region with an X. the probability that you're in B complement, or not in B, given that you are in the region AC, or both A and C, is equal to 1/8. So what that's telling me is that the region I marked with an X, this triangular sort of region here, is 1/3 of the total orange part. And so we know that the total orange part has a probability of 1/8. 1/3 of 1/8 then is 1/24. So the probability that you're in the center region would be the other part of that 1/8, right? So let me switch back then to formulas. Let me find what I had open here. Okay, so the formula way to see that here is going to be, so you can see here I had this same orange region. The formula version, let me just create some white space here. You've got a few different ways you can do this. The probability of, excuse me. So what we're after ultimately here, if we go back to our question, we're interested in the probability that you're in all three regions, A, B, and C, right? So that's that center region here. That's what we're after. So the formula version of doing that here, we're going to make use of the probability of A, B, C. There's one way we can write this, and if you look in the book, I apologize, I don't have the page number. I only have the Kindle version here. If you look in the book, there's a formula for conditional probabilities across for 3 events. Let's see if we can find that. I really wish I had page numbers here. So, bear with me. Okay, here it is. So this is the very beginning of section 2.3. You get this general formula here. Probability of A1, A2, A3 equals the probability of A3 given A1 and A2 times the probability of A2 given A1 times the probability of A1. Now, what we need to do here is just take the information we were given and map the letters correctly to fit this general formula. So the good news is that we can do this in a way that is comfortable. So we can say we were given in the problem, we were given the probability of C given A, and we were given the probability of B complement given A and C, and then we were given the probability of A. So the last piece I'm going to want in my formula is going to be the probability of A. That's the one that I know unconditionally. I also have one where I know the probability of C given A. That's going to match up with that second piece here. And then I need the probability of B given both A and C. And if you look at that, that matches up with the book's version, right, where I've got the probability of B, which is A3 there, given both A and C. And then I've got the probability of C given A, and I've got the probability of A. So that should match up correctly to our book formula. It's just a matter of choosing the right pieces of information. Now, I don't have this piece. I don't have the probability of B given A and C. What I have instead is the probability of B complement given A and C. And so again, if we go back and we look at the original problem, we'll see that B complement given A and C is equal to 1/3. But the complement rule just says that an event and its complement added together have a probability of 1. And so the probability of B given AC is going to be equal to 2/3, right? 1 minus 1/3 is 2/3. So I now have all 3 pieces. And you can see that what we're doing is we're multiplying. We had the 1/2 for the circle for area A. We had the 1/3 for C given A. Excuse me, that was That was 1/4, not 1/3. So we had 1/2 for A, 1/4 for C given A, and then we'll have 2/3 for B given AC. So now all we have to do is multiply those together. So it's going to be equal to 2/3 times 1/4 times 1/2. And if you multiply that out, you should get 2/24 or 1/12. All right? Okay, so Jamie's the one who asked about it. She just had to leave, so there it is, but it's being recorded for her. Any questions on that?
And it's to write the formulas or the 1/12 in Word. Can you show that again?
How did I do this formula in Word?
Right, like how are you able to put the 2/3 into 1/4?
How am I able to create the fraction so easily? Is that what you're asking?
Right, yeah.
Okay, so yeah, it's a shortcut that, so far as I can tell, usually works, or it always works for me. If I want to do 2/3, for instance, I type 2/3, and then if you hit the space bar, it seems correctly to interpret that as a fraction every time, and it'll change it to a fraction. The long way to do it, of course, would be to go to the design and then choose to do a fraction, and then you can go back and put in 2/3. But every time I've tried it, it handles that slash correctly. So if I want to do 1/4, I would type 1/4, hit space, and it changes it.
I think I'm more interested in, like, if you write a formula, like for example Bayes' theorem,
Yeah.
how will you write, the numerator by denominator, the whole formula?
Okay. Yeah. So here's Bayes' formula. So do insert equation, and then the probability of your hypothesis given some evidence E is equal to, and then I think there's no easy way to do the fraction except just to go up and choose fraction, and then choose the layout that you want, and then you could do the probability of your hypothesis. I'm just typing this out with characters, right? Probability of your evidence given the hypothesis. And then go to the denominator and do the same thing. Like that.
Great. Sure. Thank you.
Okay, yep. And then I'll just finish it. Not hypothesis, probability of evidence given not hypothesis. Like that. So it's not quite so easy because you've got more complicated formulas, but that's the way to do it. The really slick way would be to learn LaTeX and use a LaTeX document instead of a Word document, but that is neither quick for me for teaching purposes nor particularly user-friendly. So I usually use Word for quick things. Let's see.
Hey, Mike.
Yeah. Is that Vuti?
Yeah.
Yeah.
I had a question, not necessarily pertaining to this class, but probably might be interested for everybody anyway. Do you know of, since we're all in groups, do you know of a way for us as students to share the screen with each other? Because, we're not necessarily in the same space.
So you guys want to be able to do an online chat like this and share screens?
I would. I don't know. I can't speak for everybody else.
So I believe you have access to a tool that we tried last semester, not for a class, but a bunch of us instructors. We used it for a couple of meetings. It's not as user-friendly as GoToMeeting. But if you go under, unfortunately, I can't get to it because I'm not in a group, but actually, so Mauricio, are you still there and willing to share your screen?
Yes, I am.
All right, let's see if we can get you to do this. So let me, let me make you presenter. So let's try this. So Mauricio if you go into our course again, I don't promise this will work, but you can try it and let me know. If you go down to collaboration, so right under the group name collaboration, this is a tool in Blackboard where you can host sessions online. It works very similar, so click Create Collaboration Session. You can give it a name. You can say when it'll be available, and then
yeah, so we put a date. Available, yes. Let's see, this is for today.
and then choose tool for the session, virtual classroom, and then you would submit it. That should create something that you can use through Blackboard, and then you might have to go back and edit it. But see, this is complicated, and I can't see what you guys see, so it's hard for me to walk you through this. Yeah, see, it doesn't even show.
This is a virtual classroom.
Yeah.
You know what I've used in the past? I've used Google Hangouts.
Yeah, you guys are welcome to use that or Skype or any other tool you guys want to use. It's really, it's fair game. Unfortunately, GoToMeeting costs a fair bit of money, so we don't have that available for student use. You guys would have to pay for it. But I think, doesn't Skype let you have up to a certain number of users at a time?
I don't know about Skype. I know I've used Google Hangouts, and you can have like an unlimited number of users.
Okay. So that's another option then, and by all means use those tools. I don't want to limit you guys there, and I'm sure you guys are all in, most of you are in 607 as well, and those who aren't are probably in my 621 data mining class. By all means use other tools if they're helpful, but
so in this thing, is there a screen share?
Yeah, that looks nothing like what it looked like for us. and there was a screen share for us. So I honestly, that's available if you guys can figure it out. That looks like you can just do private messages. So I would investigate the Google Hangout approach then. And I'm happy to try and help figure that out. I always use GoToMeeting because I have it, so I've never had to use Google Hangout. I know they use it with Coursera a lot. So by all means, give it a try. Just be aware that I won't have access to that, so I may not know what you're doing there, but that's not a problem for me. I'm going to grade the final project that you submit, so the only time I go in and look and see what's going on is if you guys have something that you can't figure out. If you email me or let me know that you're discussing something and you want me to weigh in, I need to have access to it then, but I don't know why I would need access to your sessions. So, and I know Andy will be just as happy to let you guys use stuff like that in 607.
I came across something called like Join Me or something, but I haven't had a chance to try it out yet. But it seems to offer the ability, but I haven't had a chance to try it.
Yeah, Brian Rowe, who's another instructor in the program, used that once for a course as well. So I wasn't in the course, so I didn't really see it, but I think it works fine. And I think it's free.
Yeah, we said in the past. I'm just not sure if it's just like a single user, like the free version. I believe you can only share your screen with one other person. I'm not sure that you can do it with multiple people.
Okay. Yeah, so worth investigating, but
Well,
obviously
TeamViewer is a great software.
What's that?
I've used TeamViewer in the past, and TeamViewer.
TeamViewer.
Yep.
Okay. Okay.
Okay.
Yeah, any of these tools, if you want to use them, are and let me know what works well, and I'll share, or just you guys share with everyone else too. Yeah, absolutely.
I have used this in the past with 2 other people, so yeah.
So the question is whether it'll work for a total of 4. Right, because some of the groups do have 4 people.
Never mind.
Yeah. Well, go ahead and figure these out offline and just use the forums to discuss with your group. And as I said, if you find something that works well, please share it with everyone. The Blackboard Collaborate tool is okay, but it's complicated to figure out. You have to download some stuff to get it to run. It requires Java. So just, be prepared for that. And I think, I'm not sure why that session that you created doesn't even show up, but this might even be the older tool that they have. So I'm not sure. I'm not sure whether it's.
Maybe since I'm running a Mac, it's just has a different version.
Yeah, it could be. It could be. When I used it, I was on a PC. And I'm on a PC right now. I do have a Mac, so I try things out on both usually. But okay. So, other questions. So I'll leave you guys to figure out your collaboration, but I mean, if you can figure it out, it's fair game. We don't want to restrict you guys on that.
Mike, I'm interested to learn 2.30. I couldn't solve it, both just as a problem and also using the R program.
Yeah, and we're going to spend our meetup tomorrow night on R. So we're a little bit behind schedule in terms of learning R. So tomorrow's meetup is going to include a substantial introduction to R, but we can go through it tonight quickly as well. And one thing I want to say about R, and you'll hear it again tomorrow, is what we care about primarily is that it works. We don't expect you necessarily to write the, and Mauricio, I'm going to steal presenter back here again. Thank you very much.
Okay.
We don't care so much whether you've got the most efficient code in this class. That really, it's, we want code that runs correctly. So, and 607 as well, we want code that runs correctly. Optimizing it will be important later on. If you're working with massive data sets, obviously you're going to have to spend some time optimizing. But generally we take a twofold approach, or at least I take a twofold approach. I write code that works, and then I optimize it. And one of the reasons for that is that sometimes you're working with data sets that aren't all that big, and the optimized version might save 20 seconds on a 10-minute analysis. And really, how many times are you going to run it that it needs to be optimized? If you're going to invest 5 hours of work optimizing code that you're going to run 6 times and save a total of 2 minutes, that's really not efficient. So in this class, really, it's just about getting it to work. Now, having said that, let's take a look at the problem. Okay, so I'm going to do a more general case of this. Again, I'm going to create a new file here. And let's do a case where you've got 10 envelopes. Actually, 10's a little too many to fit on the screen. Let's do 8. So I'm going to just create 8 envelopes here. Oops. All right, so let me create our 8 envelopes. And this problem, I'll go back to the problem for a minute here. This problem is loosely based on the Monty Hall problem, which is a famous problem, but it involves 3 doors, not 4. It's in the book, but this is just an expansion of that problem to an additional door, in this case envelope. So let's take a look at the idea here. The prize is behind one of the envelopes, or in one of the envelopes, right? So let me just label these. One through 8. And then what we'll do is just say, we'll arbitrarily specify which envelope you're picking and then which envelope actually contains the prize. Because we can just shuffle everything up. And there are going to be 2 possibilities. One is that you pick the envelope that has the prize right off the bat, and the other is that you pick one of the other 7. So let's just say, for the sake of argument, that the prize is in envelope number 1. And let's consider 2 scenarios. So the first scenario we'll consider is that you pick envelope number 1. What is your probability of picking envelope number 1? Well, if you're choosing at random, you've got a 1 in 8 chance of picking the correct envelope, right? So if there's a 1/8 chance that you pick the correct envelope, let's make a note of that. Okay, so there's a 1/8 chance you pick the correct envelope. Now, if your strategy is to stay with the envelope that you pick, you would win here, right? And if your strategy is to switch, you would lose. But let's suppose you actually pick envelope number 3. Okay, so you've picked number 3. Now, if you stay with the envelope that you picked originally, you would lose. And if you switch, you would win. But remember, we said there's a 1/8 chance you pick the correct envelope. There's a 7/8 chance that you pick the wrong one. If you pick the wrong one, the host is going to remove 6 of the envelopes that remain, right? But we know the host will not remove the one that has the prize. So if you pick the wrong envelope, the host is going to remove all of the other wrong envelopes. So if you switch, you're guaranteed to win. All right? Now, you had a 1 in 8 chance of picking the correct envelope and a 7 in 8 chance of picking the wrong envelope. So if you switch, you would win 7/8 of the time, and you would only lose 1/8 of the time. If you stay with the original envelope you pick, you're only going to win that 1/8 of the time that you picked the right envelope. Any questions up till that point?
Nope.
Okay, great. Now, when we go back down to the case of 4 envelopes, there's a 1 in 4 chance that you pick the right envelope. So by switching, you'd have a 3/4 chance of winning, because you'd have a 3/4 chance of having picked the wrong envelope, and then switching wins. So, but I think if we show a bunch of envelopes like this, it becomes really easy to see what happens and why you have a 7/8 chance of winning. You win if you adopt a strategy of switching. You win 7 times out of 8 because you have a 7/8 chance of picking one of these wrong envelopes, and only a 1/8 chance that you started with the right one. So, and that can be a little bit counterintuitive because it seems like once we remove all those envelopes, it's just 50-50. But remember, you had a 7/8 chance of ending up in the case where you had the wrong envelope to start. So for the original problem in the book, the answer is actually that you have a 3/4 chance of winning if you switch, because you had a 3/4 chance of picking the wrong envelope initially. So you should switch because it gives you a 3/4 chance. And what we'll do is run a simulation now that verifies that. So I tend to work in RStudio, and you can see I'm actually working on some scoring trends and some hockey data. So let me just save that and open a new file here, and let me make this a little bit bigger for those of you that have small screens displaying. And let me just clear out my workspace so that we don't actually accidentally work with something from what I was doing earlier. Okay, so what I've got up in this top left quadrant here is a file that I can save, a text file that I can save that just does R code. And so what we want to do now is simulate based on your strategy of switching versus staying, and see if we can figure this out. So what I'm going to do is create a set of envelopes, and there are shortcuts for what I'm about to do, so I'll actually show you a few of those here, but I'm going to create just a list of envelopes 1, 2, 3, and 4, and I'm going to make a comment here at the beginning. So a pound symbol or a hashtag, if you prefer, is how we start a comment in R. And it's a 1-line comment, so if you go to the next line, it's not a comment anymore. And I'll just make a note. We have 4 envelopes, and we'll assume without loss of generality, which we usually just write WLOG, but I'm going to type it out this time. Envelope 1 wins. All right. We could simulate that each time. We could say each time let R pick randomly which envelope wins, but that's unnecessary. We'll just assume envelope wins, and then envelope 1 wins, and then what we'll do is say we're going to pick at random an envelope each time, and then we'll see how often each strategy wins. So we have 4 envelopes, so I've created a vector of 4 envelopes. The C means concatenate into a vector. It's the way that we create a vector. And if you want the help documentation on a particular function, the way to get that in R is to go down to the command line here and type question mark and then the command name. So in this case, it's just a C. So I'll type question mark C, hit enter, and you'll see we get it's actually the combined function. And it'll give you the details on how to create a vector using the combined function. And so what I've done is create a numeric vector with 4 entries separated by commas, 1, 2, 3, 4. An alternative way of doing that would have been to say this. Because it's sequential, I could have said create a sequence starting at 1, ending at 4, and actually let me just say from equals 1, 2 equals 4, by equals 1. And that'll create a sequence from 1 to 4, iterating every 1. And you could do, from 1 to 8 by 2. You can do all sorts of different things with this. So if I go down here and I type question mark SEQ, we get the help file on sequence. And one nice thing about this is that there is a default order to the arguments. And you can see right here, it's from, to, and by. And so I could also have left out the keywords, and I could have said envelopes is a sequence from 1 to 4 by 1. But the nice thing is that I can do it in other orders if I specify the keywords. So I could say 2 equals 4, from equals 1, by equals 1. I can put them in different orders if I want to. So I would encourage you guys, if you're using functions like this, use the keywords for the parameters, from, to, and by. If you don't, it's okay if you get them in the right order, but it can be harder for someone else to read your code. So I would encourage you to do that. It also allows you accidentally to put them in the wrong order, and it still works. Anyway, all of those commands would create the same vector in this case, from 1 to 4. And if that's not enough, there's also, for sequences that go by 1, you can just do 1:4. And you can see over here the value for the variable envelopes is now an integer vector with 4 entries, just 1, 2, 3, 4. However, for our purposes tonight, I'm going to go with this version, which creates a numeric vector. The difference for your purposes between integer and numeric is non-existent. There's no difference, so we won't worry about that. Now, what we want to do to simulate this, again, is we're going to... What's that, Mauricio? Oh, maybe it wasn't meant for us.
Oh, no, I'm sorry. I thought it was muted. Sorry.
Oh, that's okay. That's okay. It'll happen. Okay, so we're going to pick an envelope and evaluate each strategy. And I should say pick an envelope at random. All right, so let's call it choice. If you restrict your variable names to upper lowercase letters and numbers, don't start with a number, but you can include numbers and include periods, you'll be safe. So I could say choice.envelope, for instance, and that would be a reasonable variable name, but that's a little bit longer than I need. So for this, I'm just going to call it choice. And now what I'm going to do is use the sample function. And again, if you don't know the parameters for sample, you can do question mark sample down on the command line, and it'll bring up the syntax for you. So I'm going to use the sample function. And n is the number of items to choose. Excuse me, I don't want to use n. X is the vector of items to choose from. So I'll say sample x equals envelopes, because I've already got that list of envelopes up here. And the nice thing about this is that if I later on want to change my list of envelopes, I only have to change it in one place. Right? I don't have to change it down in this code. I could have done sample x equals C1234, but then I'd have to change it everywhere I sample. And then I'm going to say size equals 1, because I'm just going to choose one envelope at a time. And then I'm going to say replace equals false. It turns out if for a sample size of 1, it doesn't matter whether replace is true or false. That just means whether I'm sampling with or without replacement. But if you do a sample of size 1, then it doesn't matter, because you're going to not replace anything anyway, even if you say true. And then I'm going to say probability equals null. I could leave it off and it'll default to that, because you can see over here it says probability is a parameter and the default equals null. But you can give each envelope a different probability if you give it a vector of probabilities. So for instance, if I wanted to have the envelopes be of different probabilities, I could give it a list of those probabilities. But I don't want to do that, right? Each envelope is equally likely, so I'm not going to do that. So I'll just say the probabilities are null, or I could just leave it off. Or I could give it a list of equal probabilities. Now, if I do this, you'll see that I ran it once and I got a choice of envelope number 2. So now I'll create a new variable called winSwitch, and I'm going to say if else. So I'll create an if then else statement here. And this is similar to an if else statement in Excel, if you've used Excel. And what I'm going to do is give it a condition. So I'll say if choice equals equals is the way of comparing. And we said envelope 1 was the winner. So what I'm saying here is if my choice is envelope 1, then winSwitch is going to be equal to 0, because I'm not going to win, right? I'd switch away from the winning envelope. Otherwise, give me a 1 for winning. So let's just make sure this code makes sense here. I'm saying if else, so I'm going to give it a condition. If the condition is true, then I output a 0. And if the condition is false, I output a 1. And so I'm going to indicate that I win by saying 1. And then what I'm going to do in my simulation is add up the number of wins. Okay. And then I'm going to do the same thing for win.stay with the same envelope, right? So win.stay. And I'll say if else. If my choice, again, equaled envelope 1, now I win. So I'll say if that's true, give me a point. Otherwise, give me no points. Right? So what happens here, I made my choice. It was a 2. WinSwitch equals 1, because by switching I would win. WinStay equals 0, because by staying I would lose. So that's one trial, right? That's not very exciting. We've done it once. So the last step is going to be to run this a bunch of times and then just add up the number of wins in each strategy. So what I'm going to do is create a loop that runs 10,000 trials. Why 10,000? That's a fairly standard number for this kind of simulation. If it's a much more complicated simulation, you might only run it, say, 1,000 times, just because it might take a while to run. And here I'll make a comment that loops in R are very inefficient, but 10,000 is a very small number relative. For computers, 10,000 is pretty small. So this will still run very quickly. But if you were running 1,000,000 trials, you would not want to run loops. You'd want to write what we call vectorized code. And you'll see a little bit of vectorized code throughout the first semester here. And you'll get better at that as you go. But for now, we're not going to worry about that. It'll run fast enough. So a for loop. And I'll use a dummy variable I for my looping variable, for I in. And here I'm going to use the sequence from 1 to 10,000. Remember I said we could use a colon between the starting and end points as a shorthand for the sequence. But you could write a sequence function here and put it in there as well. You'll get more practice with that as you go. So I'm going to run a loop that runs 10,000 times. And before I run my loop, I'm going to start a count. So WinSwitch total, and I'll say that that's equal to 0. And WinStay total is equal to 0. So I haven't run any trials yet, so I haven't won with either strategy yet. So they're both equal to 0. And notice I'm using this arrow as my equal sign. In R, we typically assign values using this arrow notation. It's a less than sign followed by a hyphen. You can use the equal sign, but that can, in rare occasions, that can actually cause undesirable behavior. And so we tend to use the assignment arrow. The other nice thing about the assignment arrow, if I wanted to, I could write 0 and write a right assignment arrow. That would actually work as well. So if I run that line, you can see over here that it correctly assigns 0 to win, stay, total. That's primarily useful on the command line when you've just written an extremely long command and it calculates a result, and then you realize that you wanted to save it. So if you notice on the command line, I can hit the up arrow and it shows me the previous line of code, and I can actually do that through all of the previous lines I've run during this session. So if you calculated something and you wanted to assign it, at the end of it you could just type the right assignment arrow and assign it to X. So that's a useful thing to know, but we don't need to use that in our simulation. Okay, so I'm going to write this loop, and what I'm going to do is I'm just going to copy this code that I used up here right into the loop. And you'll even notice that RStudio indents it for you nicely to help you see what's in the loop. So what this is going to do is 10,000 times it's going to make a choice of envelope, and then it's going to calculate whether you win by switching, and then it's going to calculate whether you win by staying. Now, we could do a shortcut there too, because you know that if you win by switching, you're not going to win by staying. So you could just do something like win stay is equal to, the absolute value of one minus the other or something. But this is just as easy. And then what I'm going to do is after I've calculated it, say win switch total is equal to whatever was in the variable to begin. Plus the new win switch value. So if I won by switching, it'll add 1 to the count of how many times I've won by switching. And then I'll do the same thing for win stay. Unfortunately, in R, there's not a convenient shortcut like there is in other programming languages for just adding 1 to a value. Right? So in C++, for instance, we could just type something like this, and it would just add 1 to win.stay. Right? You can't do that in R. It's not available. Somebody somewhere probably has written a function that does it, but you'd have to import their package, and it's more hassle than it's worth. Plus, this code is easier for a newbie to understand. So if you give this to someone else, it's easier to see what you're doing here. I'm going to do just one more thing to clean up my code to make it run a little bit easier so that I could change numbers around. I'm going to say that capital N is the number of trials that I want to run. And the reason I might want to do this is because I might want to do additional calculations with N later. And this way I'll be able to change it in just one place at a time. Okay, so that loop will run 10,000 trials. And then I'll say win switch percentage is going to be equal to win switch total divided by N. And then win stay percentage is going to be win stay total divided by N. So that'll do the calculations. And this is, you can see now why I decided to make N a variable here separately. This way, if I want to change it to run 100,000 trials, I could just change it in the one place, not have to change it everywhere you see an N. Okay, and that's it. That code should run our simulation. This is now unnecessary code here, so I'm going to comment it out. See if I can remember how to do that. No, I can't, so I'm just going to do it by hand here. So there's a way to comment out several lines at once. I got to look it up. Okay, so what I'll do is we've already got envelopes as a variable over here. We can see it in our list of variables. I've already run these, but I'll run them again just to be sure. And you can run code in RStudio by highlighting the lines you want to run and hitting Control-Enter. And then I'll run the N equals 1,000 line, or 10,000 line, and it'll store that variable. And now I'll run my loop, and we'll see this will run pretty fast. And you can see it's already done because I has already taken on the value of 10,000. And then let me just calculate these percentages. And we can see over here in the list of values that win stay percentage, because I've zoomed in, it's cutting off the last bit of the variable name, is 0.2502. And remember, we said the theoretical value for winning by staying was 1/4, or 0.25. So our simulation got very close to the true value there. Win switch percentage is 0.7498, so very close to the 3/4. I can run it again if I want to, so let me just run the loop again and calculate those again. And we'll see let's see here. Wow. Something went
I
massively.
think the numbers didn't change. You didn't reset the count.
I did not set my... Oh, yes, thank you. I didn't rerun these lines. I got to run those lines. Yeah, silly mistake. Okay. So rerun it again. Now I get 0.2449 for staying and 0.7551 for switching. And you can run that as many times as you like. And obviously, I could run 100,000 and that'll still run very fast. So that took about a second rather than a tenth of a second. But it's already done. And you can see now I'm getting even still very close to 0.25 for the probability of winning by staying. Now, one more comment I'll make, and then I think we'll wrap this up unless anybody has any last-minute questions. If you want someone else to be able to reproduce your results, what we typically say is we call that setting a random seed for your random number generator. And R allows you to do that. You can issue the set seed command, and you can choose any arbitrary integer that you want. So I'll do 1, 2, 3, 4, 5. You don't always want to choose the same seed. You want to vary that from project to project. Otherwise, you're locking into the same numbers all the time. And sometimes it's worth running the simulation again with a different seed just to see what happens. But if you want somebody else to be able to reproduce your result, you put set seed immediately before the random aspect of your experiment. And you can see right here is where we're sampling, so I need it to be before I do that. And I don't want to do it in the loop, or else it would do the same sample every single time, and we would get really bad numbers. But I'll set it right before my loop. And so now let me run this experiment. And you can see I get a result of 0.24854 for staying. And what I'll do now is I'll run the experiment again, and I get the exact same result. It didn't change. So by setting a seed, you tell it where to start its random number generation algorithm, and then once you run the code from then on, each time you'll get the same exact result. That lets somebody else reproduce your results. So we would encourage you to do that for this stuff in this class. That'll also let me see what you're doing and simulate the same result. So it won't be marked wrong if you didn't do that, but it's just good practice for reproducible research. And that's it. That would run the simulation and show that you get a very similar result to the theoretical result. Any questions on that? I know there's a lot to this. And again, tomorrow we're going to go through a little bit more deliberately the basics of R. But that's the basic idea here.
I have a question, Mike.
Yes.
Yeah, listen, as I've been working my way through the problems, I'm starting, I think you illustrated and you presented it as, working the Venn diagram and doing the formula way as different techniques through which you can arrive to the solution of the problem.
Yes.
Having said that, I think I've also, one thing that has helped me that I understand it much better is doing the simulation.
Yeah.
Like writing, like exactly what you're doing. Now, and sometimes I feel like I have to write the simulation because I will understand it so much better if I just code the problem. You know what I mean? Even just like this in the past exercises. Now, is that an invalid thing? And I feel like I have to like reverse engineer my way through a problem, and then I'll get it. You know what I mean?
I think that that's a perfectly normal thing. I'm not, you're not weird for that, I guess. That said, for the problems for this section, other than the simulation problems, obviously, we do need the theoretical answers as well. But if the simulation helps you understand what's going on and then by doing so, that helps you get to the theoretical answers, that's great.
Yeah, but I feel like I have to like hack the theoretical answer by doing the simulation, and I don't know if it's just like this is like wrong or.
Well, I mean, that's not an uncommon thing. It's really, you know, you might not know what the right answer is, and you can't figure out the theory part. You know, for instance, let's say you're working in your group and you guys are taking on a theoretical problem. You won't do that in this course; they'll all be applied. But pretend that you did one, and you can't decide whether the answer is 1/2 or 1/5. And you go through and you code the simulation, and you agree that the simulation is correct, and the simulation is suggesting an answer very close to 1/5. That could give you some insight into where one of you was going wrong on the theoretical work, right?
Okay.
And that's normal. The other thing is, as you go through this course, you're going to see the first half is pretty theory heavy in probability. When we get to the statistics part, we're going to get much more simulation heavy. Because in statistics, we often don't know the theoretical answer. We just don't know it. And so we have to use data to generate anything that we know. And so we'll focus more on simulation anyway, because it just works better.
Okay.
Right? I mean, if you're out taking a poll, you don't know the theoretical percentage of Americans who would vote for or against a particular issue, right? A particular position on an issue. So you simulate that. You run statistical analyses and you estimate it. So that's the more natural approach anyway, I think.
Okay.
But you do need to have the basic theory in order to understand what the statistics tell you. And also when you get to the data mining classes, we use some theoretical techniques, so you have to understand those, and they're all based in probability.
Okay.
There's a wonderful technique called the naive Bayes algorithm, and it's based on Bayes' theorem, plus the assumption that all the variables are independent. And if you know the basics from the first few chapters of this course, you can actually understand how that algorithm works very easily. If you don't know the basics, then it's just sort of, okay, I think that makes sense, but you probably won't really be sure.
Right.
So it's a delicate balance. We tend to lean more toward the applied stuff in this course, so more toward the simulation. But we do need to want to give you a basic understanding of the theory. So, but I would say absolutely do the simulations. If that helps you, that's great.
Right.
You can even turn in the code with your solution, and I'll take a look at it. And that's, you know, I'd love to see that.
Okay, perfect. Yeah, because like I was working on this hemophilia, on the three prints, and that don't have hemophilia, and if the queen, is a carrier or not. So, and I'm like, oh my god, I can't do this quite from the get-go. I need a simulation, please.
Well, this stuff is hard. I'm teaching an introductory statistics course for undergrads as well, an actual classroom course here in Kalamazoo. And I spent 5 minutes reassuring them that the stuff is hard. It's not that they're stupid, right? Because they were really struggling with some of these problems and in their homework. And I said, no, it's hard stuff. So keep with it. And the same is true for you guys, right? Keep with it.
All right, cool. Thank you, Mike.
So, all right. Any other last minute questions here? Okay, so we do have a meetup tomorrow at 7:45. It's those of you that are in 607. You have your 6:30 meetup with Andy, and then I'll be joining at 7:45 in our link. And so most of it will be a thorough introduction to R. I will also have some time open for questions on problems you're working on from the new material, or the old stuff if there's still something bugging you. If you really want to see something, shoot me an email ahead of time, and I'll see if I can accommodate that. But if you didn't email me ahead of time, you can also ask in the chat window during class, or even just speak up, and we'll cover it. Again, thank you for your patience with me. Obviously, it's not ideal for me just to disappear for a week, but I was having some heart trouble, so I had to deal with that. There was really no choice, and Andy is more involved now, so we'll make sure that doesn't happen again. So I wasn't expecting to have problems in the first week of the course, right? So, all right. So I guess I'll see you all tomorrow, or I'll see you all through our GoToMeeting session tomorrow. Let me know in the meantime if there's anything you need, and I'm going to keep trying to get caught up on emails and discussion forum stuff.